Hello. So for the problem that I'm going to be explaining today, it was question one and question two. And then just for some context, question one was the one I did understand, and question two was the one I didn't understand. And so for problem one, I kind of just started out by writing the equation, and then I started off by calculating Gibbs free energy change, which can be seen as kind of like the first thing done. And then using the formation energies of the species involved, I was able to get the 28,618 joules per mole. And then I had delta G, and I used the Ka equals exponent of negative delta G over RT. So I just plugged in the number I got above for Gibbs free energy, which ended up coming out to the number on the screen. And so then once I found the equilibrium constant at 290 degrees Kelvin, I incorporated the equation down below in order to calculate how Ka changes at higher temperatures, aka the 500, 750, 1000, and then of course the 298, which is the one we already calculated. And then I did that using the enthalpy change delta H. My calculations showed that as temperature increases, Ka decreases, which makes sense because the reaction is exothermic. So that would make sense as it changes. I also noticed that the lower the temperature, the higher the equilibrium conversion, which kind of aligns with the um, principle and our lecture notes that we've kind of already gone over. And then for question two, I understood that you needed to calculate the Kp and the Kc for the complete oxidation of the methane. So I just kind of started off with a step up and then set up, and then I had to look back at the actual um, key for this one, just because I kind of didn't really understand where to go after the setup. And then with the balanced equations, I just wanted to make sure that they were correct. Um, so after this, I just kind of identified that you probably want to start with the Gibbs free energy again, which is what we started the last problem with, because it is pretty similar to problem one. However, I just kind of wasn't sure. I wasn't really completely sure how to handle like the temperature, and like the one over T minus one over. And so I kind of had to look back at the kind of adjusting for the different pressures as well and how that affects KP and KC. And then I tried to kind of see the different relationships between them, but it's still something I'm kind of struggling with. So hopefully it will make a little bit more sense a little later on in the course. Um, and I wasn't really sure how to exactly interpret the results. So if we could go over like that in class, I think that would be really helpful. But that was all, and thank you.